this and minimise. Obviously, it goes without saying that don't close this one down.
Okay.
Because obviously, you know,
Not totally.
if it does happen, no problem. We can obviously restart.
Okay, fine.
Make a hiatus.
Yes.
So I'll go to again, I'll just minimize that. So that's now been broadcast from YouTube.
Okay.
And they use the microphone, they hear that, but they will be hearing this through the catchphrase.
Okay. Okay.
Perhaps we can ask also with your presentations on the desktop,
Yeah.
after the meeting, if you could make sure they're uploaded to the UNFCCC website.
Okay.
And that's through the CCUS.
Okay. It's okay. Yeah.
It's some events organising
Okay.
our registration, and then they're available.
Okay.
To use. And that's about it. Are you anticipating quite a high attendance or should I say low security on that?
No. Oh, you can get, yes. Yeah.
Andrew, just helping facilitate.
Tracy wants us to know the presentations through CCS.
Oh, yes. Yeah.
Yeah, please do.
Just at least on the side.
That's right, yes. Okay.
It's there, just the.
To John, it goes without saying, obviously, Google Chrome is running, which is broadcasting.
Oh, I see. Yeah.
So just be aware not to close it down because that
Yes.
obviously counts.
Yes. All right.
Good. Andrew,
Very good.
welcome to the facilitation.
All right. Good to see you. Yes. Okay. Not that I do the proper ejection at home.
Do you know they have recycling for the glass bottles? Do you know
There's
they-
bins just there.
There's a counter just out here.
Yeah, there's a-
All right. You got mine on there?
Yes.
Yes. All right.
I'll see.
they're
I'll
organic.
sit here just.
Okay. Do the tricky bit. No, very strong. I have my USB.
Please,
That's it.
how are you?
How are you? Yeah, good. Hi, David. How are you? Everything's okay?
Everything's great?
I have my USB.
Yes.
Use it.
Yes.
Oh, is this your computer?
Any chance the IEA on?
No, we did not cancel that this time.
Okay.
Yeah, because I need to be here.
All the
Yeah.
نحن من ثلاثة ظن وأربعة. كم طويل أنت؟
CCS.
Oh, yes, yes, yes. لا لا يعني لا هم مؤتمر
ما ابغى باكر في بعد
لا باكر في الاجازه بس الشوارع زحمه والله
اليوتيوب 5 دقائق ولا شيء.
بس وانت
في اليوتيوب 5 دقائق شوارع مصممة. كيف
الليله
أنا ماخذ
I know, I don't know exactly.
What's the sequence? David's introducing me, Eleanor, and then the Fiesta Resistance.
So the later.
You're first.
I'm last as well. Yeah.
Yes.
I've got a small speaking slot as well.
Yeah.
Yeah, right, so that's just going to be introductions. Yeah, so we'll also have a bit of a very good.
Yeah.
Yeah, okay. Introduce you to Elena. You probably know Elena.
Hi.
How far did you have to?
Hi, nice to meet you. I'm Elena from IEA, International Energy.
Nice to meet you. So your presentation yesterday.
It
It was interesting.
wasn't,
Information.
they told me it's 3 slides.
It's a talk on, with some questions.
And with
Yeah.
questions, couldn't really
And it was
present
very interesting.
properly. Well, thank
Very
you.
interesting. So I assume we don't see the slides when we present now. Yeah? Okay, so you control.
Especially if we move it.
Okay.
I see, yes. Right, should we start?
Do you know what those boxes are?
No, I assumed some advertisement maybe. Or distress.
Right, good morning, everybody. I think we'll get started because we've got an hour and a half here and lots of material, and we will be finishing at 1, partly because that's when I have to leave. So good morning, I'm your moderator today. I'm David Hone from Shell. I work in the Shell Scenarios team, and you'll hear a bit from me later on the status of CCS in our company. But today we're going to hear about the global status of CCS, carbon capture and storage, and the progress made over the past 2 decades. This is a critical technology for the Paris Agreement. And in fact, without it, it's unlikely that the goals of the Paris Agreement will be met. And perhaps for a lot of people, that penny hasn't dropped. There's still a thinking that CCS is a sort of a sideline technology that might be important, but it's quite the opposite. It's going to be critical in industrial applications, and it's going to be critical in achieving what the Paris Agreement calls a balance between remaining emissions and sinks. So our pathway to net zero emissions. So today we've got, as well as myself, 3 speakers who are going to take you on that journey and give you a better understanding of where CCS is today and perhaps where it needs to go. The event today is run by the Global Carbon Capture and Storage Institute, and their remit is really to progress the CCS agenda globally. And the first speaker will be John Scowcroft on my right, or on the left from the audience perspective, and he leads the Global Carbon Capture and Storage Institute in Europe. He's got a background from Eurelectric, and he's going to be talking about the status of CCS today. And then we have from the International Energy Agency, Elena Levina, and she has over 20 years international experience in climate change and energy policy, and she'll bring to you the IEA's perspective on the role of this important technology and the role that it plays, at least in the medium term, in the mitigation challenge that we face. And then we'll hear some real practical experience from Arafat Al-Yafai from the United Arab Emirates. And he's the CEO of the Abu Dhabi Carbon Capture Company. And it's a joint venture between ADNOC, the Abu Dhabi National Oil Company, and Masdar, which is a group set up in Abu Dhabi that's really looking at the alternative energy green agenda for Abu Dhabi as a whole, but also spreading its wings much wider. And what you'll hear is that Abu Dhabi has become one of the world's leading practitioners of CCS, recognizing the importance of this technology in the years ahead, but also in particular for the oil and gas industry. So we'll get going, and we'll start with John, who's going to talk about the status of CCS.
David, and good morning, everyone. I want to pick up some of the points that David has been making in his introduction and take you through where we are with CCS at the moment. And I think, first of all, I'll just say a little bit about the Institute. We were established some 7 or 8 years ago with an objective of accelerating the deployment of CCS globally. Our vision for CCS is that it is an integral part of a low emissions future, and we do that through fact-based advocacy and authoritative knowledge sharing. We're an international membership organization. We have offices around the world, and we have membership from governments, global companies, small companies, research outfits, and non-government organizations. So that's who we are, and this is where we are. Well, first of all, I think we need to put the thing in perspective, that fossil fuel demand is growing and reserves are robust. And even if you look out to 2040 and you see that, in fact, the the contribution of fossil fuels has diminished in percentage terms. In actual terms, we are still going to be reliant on fossil fuel. So the question is really, when we look at CCS, I always put it in four terms. One is, do we actually need the technology? Does it work? How does it compare in cost with other low carbon technologies? And then finally, is there enough storage space for us? And then I will finish with some policy recommendations. So first of all, do we need it? Well, if you look at the Paris Agreement ambitions, the red block is basically business as usual. That is where we will be, somewhere between 4 and 6 degrees warming. The Paris INDC pledges take us down, but there is a gap there which has to be filled to a large extent by CCS. If you look at it as a part of a portfolio of low carbon technologies, you'll see, according to the IEA figures, we will be contributing CCS about 12% on that journey to the 2 degrees scenario. Now, if we break that 2 degrees out, that 12% out, one of the interesting things that comes out is that most of the deployment will have to be in non-OECD countries. And again, if we break that out further between the power sector, which is usually regarded as the main recipient of CCS, you actually find that a large percentage of it is in the power sector, but there is a very significant portion of that which will be in other industries. And in those other industries, it is very often the case that CCS is the only way that they can reduce their carbon emissions. So that's another way of looking at it. If you look at the top industry and other sectors, you'll see that, okay, energy efficiency is a big part of that. But really, switching and CCS is going to deliver a significant portion. Whereas the power sector, you can see renewables is going to be the main driver in reducing emissions from that sector. The other question is, can we do it economically? And this is taken from the IPCC's AR5, and basically they ran a whole series of models taking out one technology. And the thing that really hits you there, if you look at it, if you don't have CCS in the mix, it's going to be some 160% more expensive to meet the 2 degrees scenario objectives. I would add that, in fact, some of those models couldn't even do that without CCS. So they couldn't even get to the 2 degrees without CCS. So we've got a task, and it's an important task. At the moment, if you look at all the projects that we are, facilities we're expecting to come online, we will be storing some 40 million tons per annum. However, if we're going to reach anywhere near the 2 degrees by 2040, we have to be storing about 4,000 million tons. And that is a significant step up. And it's one of the things that we really need to get our head around. And again, you'll see that most of that is in non-OECD countries. So where are we? Well, at the moment, we have some 17 plants in operation. We have another 5 under construction, and some of those we are expecting to come online fairly shortly. The worrying thing there is, if you look on the left-hand side, the projects that are coming through, really the pipeline is not replenishing at the rate that is needed if we're going to get from that 40 to 4,000. And once again, you can see, if you look there, that the 2 areas that are really dominating this are North America and China. So that gives you an idea of what we have. The blue ones are the actually operating ones. The green ones are in the execute stage, they're being under construction. And orange are the ones that are really pushing through towards final investment decision. Again, you will see that North America dominates, and driving that is very much the enhanced oil recovery. Again, if we look at it from industry and storage type, again, The interesting thing there is, although the power sector is regarded as the main beneficiary, most of the existing projects are in other sectors, the oil and gas industry, fertilizer, and others. So, I'll put it rather bluntly there, is it too expensive? So how do the costs compare? Well, I think one of the things we have to do is work out apples and oranges, and there are a number of ways of looking at these costs, and the most relevant one, or rather the most used one, is the levelized cost of electricity. Now, and in fact, my next chart is based on levelized cost of electricity, but I think one of the issues there is it the best metric for measuring the impact of these various technologies? I think one of the problems is that they look at each technology in isolation. And if you're operating an electricity system, you actually need to have a variety of plant there to cover a variety of needs. The important thing is you have dispatchable plant to fill the gaps when the non-dispatchable plants are not operating. So with that caveat, let us look at those figures. Well, this is based on Australian information. Each power system has its own peculiarities, but here you will see the two green slots are the CCS. And you will see that it really sits in the middle of those technologies on both capital costs and operating costs. And really, the point is that CCS is competitive with other low carbon technologies. And from that point of view, I think it's important to recognize that. So that's, is it working? How does it compare with other technologies? Where are we going to store the CO2? This is based on something we're about to publish, our storage resourcement assessment, and it looks at how much we know about the storage resources around the world. And just to look at it, basically, we're looking at a regional assessment, what's the scale of storage assessments in a country, and then the level of maturity, how granular is this data? And basically, if I go back to the other chart, you can see the darker the color, the more information we have. Now, I have to say this is one of my favorite charts. If you look at this, it is looking at the scale of investment in clean energy. And on the right, you will see some 2.5 trillion has been invested. This is not support, this is investment, has been invested in clean energy over the last few years. The small blue line on the left-hand side is the amount of money that has been invested in carbon capture and storage. So the point is, if you look at the scale of renewables investment, it's based on strong policy measures. And really, CCS globally has not enjoyed that sort of policy support. Sure, in North America, the business case for enhanced oil recovery has driven deployment, but from really to get CCS delivering at the same level as renewables, you need this equivalent policy approaches. And the big question is, how do we actually get CCS onto that curve? So, just to recap. First of all, CCS is indispensable in a least cost approach to global decarbonisation. There are opportunities for cost reductions, and they are being identified. Certainly the two power plant projects in North America, Boundary Dam in Canada and Petronova in the States, are fairly confident that when they build the next plant, they can certainly reduce their capital costs by some 25 to 30%, and the operating costs will probably be reduced equally. So one of the lessons from there is learning by doing is really important. Again, it's a significant task. The urgency of deployment is increasing. Every year that goes past means that the overhang becomes greater. But deployment is not a technology challenge. The technology works. There's no doubt about that. It is more a policy issue. And the other thing we need to look at is we need to support CCS in industrial applications and in non-OECD countries. And the missing piece are the policies that spur those investments. So we need policy parity. In other words, the provision of an equitable level of consideration, recognition and support alongside other low carbon technologies. For CCS, this means predictable and enduring policy arrangements, effective and efficient CCS laws and regulation. We need to incentivize early storage site identification and characterization. There is a bit of a lag between, it can take you up to 10 years to characterize a site, and it takes you about 5 years to build the plant. And you need to bring those two things together so that we actually have the sites available for when people decide to build. We need to redouble the R&D efforts and encourage efficient development of hubs and clusters. Up until now, we have tended to look at CCS as an integrated project. In other words, power station, pipeline, storage. In fact, most power stations are in areas where there is significant industrial applications. You take the Humber Valley in the UK, that's some 20% of UK emissions, and a single oversized pipeline can actually encourage some of those industrial sites who produce CO2, but not in sufficient quantities to justify their own pipeline. It will enable them to actually become part of the solution. So hubs and clusters is really one of the ways forward for the deployment of CCS. So just to finish, we can't tackle the scale of the climate challenge without CCS. We need to implement effective policies which focus on that outcome, and we need strong leadership both from decision makers and industry to realize the potential of CCS. So I finish with a call to action. Thank you very much.
Good. Right, thank you very much, John. So we're going to press on because we'll have some time for the discussion later. Just as the speakers are rearranging, if anybody has any particular question of clarification for John, feel free to ask it, but not really a discussion question. If there's just anything on the slides that needed a bit more amplification. No. Okay, so I'll ask Elena Levina from the IA to give her presentation, and she's going to look at the deployment of CCS again from the IA's perspective. Thank you very much.
Thank you very much, David, and good morning, everybody. It's a pleasure to be here and represent the International Energy Agency. Maybe I just will start where we've just finished, why IEA is talking about the CCS. And as you know, we're an International Energy Agency developing policies and scenarios for the global energy sector. And every time we build a scenario that is for the energy sector that will be in line with the climate objectives, we just don't see how it is possible without CCS. CCS is always part of that scenario. And it's not instead of renewables, or not instead of energy efficiency or nuclear. This is an addition. So if we take CCS out, our scenarios for the global energy sector just don't get us there to the 2 Celsius degree target. And next month, we'll be releasing a new report where we, for the first time, decided to see, okay, where are we if we push all available technologies to the maximum potential, all available and in the innovation pipeline. So something that's not yet deployed, but has a chance to be deployed in the next 50 years. And that scenario brings us to 1.75 Celsius degree temperature increase by 2100, so not even 1.5. And the role of CCS is significantly increased in that scenario. So there is an importance for CCS that for the climate mitigation that we shouldn't undermine. So just to give you a brief state of where we are so we've published a report, the 20 years of CCS, because the first CCS project was built in 1996, a Sleipner project in Norway. So we decided to see, okay, what happened in the last 20 years in the CCS? And in my presentation, I'll have three short parts. So one is the previous 2 decades, then, as I already mentioned, 2DS scenario and below 2 degrees scenario, and then the next 20 years, what IEA suggests needs to be done for CCS to play its role. So in the last 20 years, actually, there have been a big achievement for CCS despite the lack of support, despite the lack of understanding, and despite sometimes opposition to this mitigation technology. So we have 17 large CCS projects operating, and new projects are coming on board. 4 more projects are scheduled to be launched this year. We also see diversification. So at the beginning, CCS was maybe envisaged or presented very often as a clean coal technology. And then that understanding was broadened, and now we have projects not only in coal. So we have Abu Dhabi Steel Project, we have oil sand project, we have gas processing projects that were actually the first CCS projects. So the portfolio of CCS projects is expanding. But what we've observed in the last 20 years is a kind of start and stop cycle for CCS. When we see political support for CCS, when we see political support for climate change mitigation, projects start developing, people start putting money and confidence in this technology. When there are downfalls, when there was a Copenhagen COP that wasn't as successful as we all hoped, there was a financial crisis later on, so there were stagnations in the CCS project development. So that brings us to a very important message that policy messages, policy support is critical for the development of CCS. And this is just the pictures to show you the IPCC report that John mentioned gave a big impetus to CCS, the CSLF forum establishment, then there was a downfalls and crisis, and then just lately, U.S.-Chinese joint announcement of supporting CCS. So the positive signals always bring additional investments in CCS. So the key lessons from the last 20 years, in addition to policy support that is important, that opportunities are there and they can be explored, and CCS could be deployed, again, with a strong policy signal and support. Storage is critical for CCS. It's a last letter in the CCS, but it's actually very often is one of the key criteria for the viability of a CCS project. So what John mentioned and what IEA keeps saying, that it's very important to invest in exploration for storage sites. Without a storage site, we cannot have a CCS project. So the main area of IEA activities, the building scenarios for the global energy sector. So you see if we move from 4 Celsius degree scenario, which is kind of a current ambition policy scenario, to 2 Celsius degree scenario, these are the technologies that can bring us there. And again, as I mentioned at the beginning of my talk, all of them need to be deployed in a portfolio. We cannot take out one of them. So CCS is a very important part of this portfolio. If you look at CCS deployment, those 15%, you see here that it's not only coal, it's gas power, it's steel, it's cement, it is chemicals, and it is also bioenergy for negative emissions that we will need, especially if we would like to move beyond 2 Celsius degrees climate target. And the challenge for deployment is huge. We'll understand that from 50 million tons in 2020. Well, today we have about 32 million tons stored. By 2020, we project 50 million tons will be stored. And to meet the climate objective, we have to have 6 gigatons per year by 2050. So the scale is huge. So we need to act fast. So what happens if there's no CCS? So we took CCS out of power, and it shows you that to replace that emission reductions that CCS would bring, we would need to bring additional renewable power capacity of 1,900 gigawatts with about 3.5 trillion of additional investments and additional challenges associated with variable renewables that will have this large share in the global portfolio. But even if we decide, okay, in the power sector, we just go renewables and we try to be without CCS. So what happens in industry? In industry, there is no really technology yet developed or envisaged that could reduce greenhouse gas emissions from steel, cement, chemicals, refineries. So 29 gigatons of cumulative emissions will have to be found somewhere else because the industry sector will not be able to reduce the emissions without CCS. So that's a really big challenge. And we don't see how it can be addressed without CCS. So if we move beyond 2DS, so these are the sectors that are responsible for remaining emissions. And you see a big share of industrial emissions there. Because the power sector is virtually decarbonized in an even 2-degree scenario. So there are no fossil fuels, or we have gas and coal with CCS. So you have this other sectors, transport, buildings, and industry that are responsible for a large share of remaining emissions. So if we imagine no CCS in industry, you have transport and building, and most of what they're doing is already related to electricity because that's the easy, or what's the most feasible way of decarbonizing transport and building to use electricity and carbon-free electricity. So you see a big challenge for industrial emissions. So next 20 years, really critical role for policy, strong policy signals at the national and international levels, and policy support like tax credits, feed-in tariffs. At different stages of CCS development, you need a different policy tool and signal to help CCS project. Second important lesson and message for the future, infrastructure approach. For CCS projects, we really need an extensive infrastructure, storage, transport. And there is a big role for governments to play in that, helping private sector to explore storage sites and also build transportation infrastructure. And maybe one interesting approach here would be hubs, storage hubs and capture hubs. So especially in a below 2 scenario, we see a lot of small CCS projects. So of course they cannot, each of them cannot develop their own storage sites. So it would make sense to develop capture hubs so that all these projects could deliver their CO2, captured CO2 to one facility. And then there will be a storage operator responsible for a storage hub where all this CO2 can be stored. And the third key message for the future is investments in research and development, because we need we need to move beyond first generation of CCS projects, reduce cost of CCS. And in that regard, so R&D spending will be very important, and international cooperation on CCS projects. And here you see a graph of R&D spending. It's not the investments that John showed, it just, but still you see a very small role in R&D going to CCS in the all clean energy and in all energy sector. So I think that's the end of my presentation. We'll be happy to answer questions.
Good, thank you very much. So once again, while we're changing speakers, if there's any particular questions of clarification, now's a good time to ask them. Otherwise, we've heard 2 very clear presentations about the need for CCS, and now I'll ask Arafat to pick up from, this is someone who's actually delivering CCS, and we'll hear about the activities going on in Abu Dhabi and the real progress that's being made there. So Arafat, over to you. Thank you very much.
Thank you, David. First of all, I'd like to thank Global's CCS Institute to invite Reyadah and ADNOC and Muscat to be here today, participate. I've been working several times with David and John in different occasions. It's always a pleasure. Before I start, I'm coming from UAE, and UAE, you may know that it is blessed with many, many things, but I'll mention a few things that are related to what I'm going to present today. We are blessed with oil and gas. Maybe some don't agree with that, but I think it's a fact. It's a blessing for the countries that produce oil and gas. And we're also blessed with a visionary, caring leadership that always think for the future. And for that, 10 years ago, actually more than 10 years ago, Abu Dhabi Future Energy Company, Masdar, was established in UAE, in Abu Dhabi, where at that time, people were wondering why an oil country starting an initiative for future alternative energies. But today we are seeing the results of that. In UAE, today the solar power tariff is around 2.45, 2.99, which is a record. And thanks to the efforts put by Masdar and other parties as well. But because of that leadership vision, today we are here. And I'm sure with CCS, Reyadah has started last year, but within few years, we're going to see an exponential increase in number of projects. So let me go to the presentation. Reyadah is called Abu Dhabi Carbon Capture Company. It is the first company specialized to capture carbon on commercial basis in the Middle East. What differentiates Reyadah from other CCS projects worldwide is that we are trying to make all the projects commercially viable. So there's no subsidy by the government or any company. And this is coming really because of the utilization factor and related to the use of CO2 for enhanced oil recovery. So CCUS is very important. We shifted slightly from the conventional CCS because we believe in CCS. However, to reach towards CCS, we have a lot of challenges that need to be addressed before we reach that point. And CCUS is the best starting point. And that's why Reyadah was established. Drivers for that, as I said at the beginning, the leadership have a vision to support global efforts for climate change mitigations. And UAE is a pioneer in the international arena, as you know, as we are here today with a big delegation in all the COPs to support international agreements and conventions towards reducing carbon emissions. And because of that, we are investing heavily into carbon capture, plus other mitigations to reduce emissions or to increase power production via non-emitters sources. So environment is a driver for Reyadah to be in place today, one of the drivers. The second driver is, as I said, we are an oil and gas country. ADNOC, Abu Dhabi National Oil Company, is our national oil company responsible of supplying the local and international markets with gas and oil. And to do so, it applies always new technologies, whether in the downstream or in the upstream side. And for that, we are preparing the platform of our fields for what we call enhanced oil recovery. As you may know, in oil companies or oil fields, enhanced oil recovery is a must-do at certain point of time in the life of the field development. And because of that, today we don't need the EOR in Abu Dhabi because our fields are so huge that they are not they did not reach the level of maturity that they need in EOR. However, we're preparing for the future, and because of that, we are we started already enhanced oil recovery. And CO2, based on US experience for the last 45 years, CO2 is the best agent for enhanced oil recovery, among others. But CO2 is one of the best that can give you the maximum recovery from the reservoirs when you inject it. On top of that, today we inject significant volumes of natural gas into our fields to maintain the pressure of the reservoirs. Now, these volumes of natural gas, if we can liberate them and use them for power generation, we're going to make less emissions from our conventional power sector. But at the same time, we don't want to lose the agents for maintaining the pressure. And CO2 is the best alternative to natural gas to maintain the pressure of the reservoirs. So that's another, I can say, advantage or driver to invest into CO2 capturing in Abu Dhabi. The third driver is, as I said, the leadership. The UAE has a new strategy of energy where it says by 2050, UAE energy sources should be 50% clean. And among that, we have to invest in carbon capture to reduce our emissions and to meet that target by 2050. It's very ambitious, knowing that today we are only at 1%. But however, if there's a will, there's a way, and we've proven several times that we can do amazing things in UAE. So that's one of the drivers towards investing into CCUS, and that's why the leadership of UAE has already. I mean, from the beginning, they said we're going to establish a company on commercial basis to do this task. So it's not a trial, it's not a pilot. We've done it 10 years ago. Today we are doing a development with a commercial company. And my challenge actually, myself and the team, is to find commercial-based projects so we can expand further in the future and even share the knowledge globally. The fourth driver is the need to create knowledge in CCS business. CCS business has a lot of challenges, technically speaking. And yesterday I was attending the innovation technology side event, where a lot of talks were there. And then that's, I mean, it's a big challenge. We have to invest in technology. We have to build the learning curve, let's say, in CCS. And Reyadah, one of its main mandates is really to gather that, or let's say expedite the learning curve and expedite technology development to make CCUS cheaper and more available, so worldwide it can be expanded. You can see in this picture 4 ministers and a sheikh attending the inauguration of Reyadah, which was done in November 2016. That was the official starting of the operation and the commissioning. We've been in this project for some years, and I'll explain that in the coming slides. So the mandate of Reyadah is to supply ad hoc group of companies with enough volumes of CO2 that are needed for their own enhanced oil recovery operations. That's the first mandate that we have. Second mandate is to create a network and be a hub for the CO2 utilization, let's say supply and demand in UAE, and in the future, during the long term, if in the region, in the Gulf region, we are going to see more utilization of CO2, that network can start from UAE, because we'll be at that time ahead of others in terms of creating a network. So that's the second mandate of Reyadah. The third mandate is really not only for the oil industry, to supply CO2 for whatever utilization that can be there. Petrochemicals are coming up. I mean, a lot of studies are going there to utilize significant volumes of CO2 that can be considered partially sequestration, a chemical sequestration, let's say, of CO2 and reducing emissions. So we are preparing ourselves to supply whoever wants CO2 to utilize. Actually, we're trying to influence the utilization by helping the industries to find ways of utilizing CO2, because it's our business. If they utilize CO2, it means I'm going to sell more of CO2. The fourth mandate of Reyadah is, as I said at the beginning, developing technologies that will allow cheaper and more reliable supplies of CO2, i.e. more CCS or CCUS projects worldwide. This is very important, because without technologies, and as mentioned earlier, we don't see enough investment so far in CCS worldwide compared to renewables. If we are going to see more investments, especially from the technology side, I think significantly the cost of capturing CO2 will go down, i.e. enabling more utilization of CO2, at least for the oil and gas sector. As a company, we have to maximize profits. So that's our vision. We have to make CO2. My vision in Reyadah is to translate CO2 from a waste into a commodity. If the demand is there, either in the oil and gas sector or other sectors, it will turn into a commodity that is needed to be utilized. And by default, we're going to reduce our emissions, total emissions or net emissions globally. So we have to turn the CO2 perspective from waste into commodity by creating demand. And that's one of the visions that we have in Reyadah, by creating a lot of demand of CO2 in the industry. To do that, we have to work on the technologies. I think technology is a key component towards achieving less emissions in the future. We started this project 10 years ago, actually, with a pilot in 2009. However, the project the first project that we're seeing today in Reyadah, the photo at the beginning, it started in 2010 with a feed, and we did our APC for 3-4 years. And in 2016, we ended the construction, and today we are seeing an operation of the Reyadah project where we capture 800,000 tons of CO2 a year, which is equivalent to around 40 million standard cubic feet per day from Emirates Steel, a steel plant, making it the first steel plant in the world to produce steel with zero emissions. This is the map of Abu Dhabi Emirate. You can see where is Reyadah is located in what was called at that time an industrial area 40 years ago, but today it's part of residential area, and that was the reason, one of the reasons actually, to start capturing the project in the steel plant. Steel plant is located in this area, and all this area today is a residential area. So you can see that to reduce the emissions in a residential area, we started the project there. And this is the exact location. We have the steel plant. It has two plants, ESI1, ESI2, and Reyadah is the tiny square here. You can see it's not that big that you require to capture CO2. Actually, the investment could be big at the beginning, but with time, and I agree with John, if we repeat this project in the future, we're going to see 30 to 35% reduction in the capex itself based on the learnings we have. So here we captured the CO2. It comes from the steel plant. Then the capturing uses conventional technology. It's amine-based system. There's nothing special. We did not use any new innovation in capturing CO2. We're using the conventional, which means the cost is normal cost. And we treat it, we dehydrate it, we process it, and then we transfer the CO2 at a high pressure, 240 bars, through a 43 kilometers pipeline. The red one is the pipeline. It goes to a nearby field in Abu Dhabi called the Reyadah field. It also transferred again to another field called Bab. So we are injecting actually in two fields the CO2 volume that is captured in. Now the capturing side is one part of the story. The other part is the injection side. And both sides have to go along each other. You cannot capture or invest in capturing without knowing how much volume is needed in the injection side. So while we were doing the project of capturing CO2 from the steel plant, on the other side, we were preparing the fields to receive that CO2 and to ensure it will be injected and add value in terms of oil production and partially being stored in the reservoir. So we started the studies in 2003, actually. It takes a long time because reservoirs are huge. We have to identify locations, we have to identify the volumes needed, we have to identify the best way of injection, the number of wells, the specification of the CO2 that is needed to be injected. And then you have to go to the decision cycle of investing certain X dollars, let's say, to prepare the fields to receive that CO2. So it took some time. We did a pilot in 2009. The pilot ended in 2011. And we learned a lot of things, technical speaking, to take the decision of supplying CO2 from Reyadah to ADCO fields. And today we are injecting the 40 million. So it took around 10 years from the concept till the operations of this first development with CO2 project. 10 years, I think with time, we're going to see a reduction in that duration. It will not take that long. However, the important thing is to capture each step learnings because in order to save time in the future. Here where we inject the CO2, the blue and pink are the existing development area. The orange is the new area that we inject CO2. 40 million is injected there in 6 injectors, and we produce oil from 3 producers. And the plan is to expand the future if we have more volumes of CO2 into all the green area. And we're expecting, let's say, double of the current volume to be captured in the future, in the near future. To do the project as well, we were very keen on reservoir monitoring. to ensure and calculate how much CO2 is injected and how much is being produced or breakthrough and how much is adding value into the oil. So there's an intensive reservoir monitoring program to see exactly where the CO2 goes inside the reservoir, if there is a leakage, if there is a loss of CO2 going to unwanted areas, let's say. What we want is the CO2 to go to do its job by being miscible with the oil. Now, if the CO2 goes to the water, it doesn't really add value in terms of oil production, but it adds value in terms of sequestration because that CO2 is lost. And I can show you in the next slide that from the simulation model, we just started the project, so we cannot give you real results, but this is a simulation model. It shows you exactly until 2060, we expect to be injecting around 600 billion scf of CO2 cumulatively. From that injection volume cumulatively, we will have a production of around 200 billion standard cubic feet of CO2, i.e. we are losing or sequestering or storing in that period at least 400 billion scf of CO2. So it's not a full CCS project. As you may know, CO2 EOR is not a full CCS as per the definition. However, we are learning a lot of things during those years in terms of capturing, transportation, and injection. But at the same time, I'm storing and reducing my net emissions by doing this project. In this case, around 2/3, 60% of what I inject remains underground. The future of Reyadah, today, the left blue 40 bar is the first project that we started, that's 40 million scf. However, as we speak today, we have huge amount of emissions, as you can imagine. We have industrial emissions, we have power sector, we have oil and gas, we have future expansions of power generation. There's a lot of CO2 coming up, and we need to capture those ones if the demand from the oil and gas sector is there, and we know it is there. So we have huge amount of CO2 available. This the estimation as of today is around 1.6 billion standard cubic feet of CO2 being emitted in Abu Dhabi only, Abu Dhabi Emirate. And that's a huge amount of CO2, and we have to find ways of reducing or capturing that CO2. And Reyadah is going to work in line with the oil and gas sector, but as I said at the beginning, also other utilizations. To summarize what I've said today, Reyadah is the first commercially based company in the Middle East to capture CO2. The first project captures 800,000 tons of CO2. The pipeline that we operate is the highest pressure pipeline for CO2, 240 bars. The amount of that we capture today is significant because it's equivalent to around 170,000 cars, the emissions of 170,000 cars in Abu Dhabi. And this number of cars, if you look at it from the perspective total number of cars in Abu Dhabi, the Emirate of Abu Dhabi, it's around 20%. So you can imagine only one tiny capturing project reduces the emissions from the transportation sector, let's say, by around 1/5. Now, the plan to capture the 1.6 billion in the future, we need around 5 projects. And you can imagine how much emissions can be reduced by doing similar projects in the future. The important thing is to continue, is to work with multiple projects to develop the technology and to drive the requirements with multiple industries, not only oil and gas sector. We have to look at different industries. Now, we have a number of challenges I would like to share with you. It's not easy to do that. It's doable, but it's not easy. However, I think with time, we're going to improve. We're going to see better technologies applied. We're going to give assurance to the decision makers that this works. So more support is expected in the future, and the more of cooperation is required between different entities, whether in UAE or internationally, technology companies. By doing this project, I've been receiving calls and contacts from different companies who claim to have new technology of capturing CO2 that can make it cheaper. Now, that's an excellent news because I think we're going to give hope to whoever who has new idea, even if it's not fully mature, but still we're going to support in order to get the best whatever available in the market. Thank you very much.
Good, thank you very much. So I'm going to give a final quick summary of what one company is doing, Shell, and then we've got a good amount of time for questions. Right, well, thanks very much. So as well as talking about what we're actually doing as a company, I thought I'd just give a very short introduction to some work we've done that really looks at the scale that CCS needs to be applied at. Not in the next few years, but in a sort of the end state of an energy transition that gets you to net zero emissions. So we heard from the IEA and from John, and we've heard from Arafat where we're at the moment, and the amount of rollout by 2050. But if you cast your mind into the sort of the second half of the century, when we really have to meet the goal of the Paris Agreement, which isn't just about this temperature rise, but it's actually about reaching net zero emissions. Remember in Article 4, it's a balance between anthropogenic emissions and sinks. And so we did some work to try and understand what that balance might look like. And this is it. So in this future world, and this is just one scenario, you've still got about 19 billion tons per annum of remaining emissions from the oil, coal, and gas sectors. And this is a fairly arbitrary split. It's rather dictated by the amount of metallurgical industries left in the world. And these are these emissions are coming from sectors which was explained by the previous speakers. There's no immediate and obvious alternative way of delivering the goods and services from those sectors without hydrocarbons. So, you know, as well as things like steel mills and chemical plants, for instance, you've got enormous sectors like aviation, shipping. And whilst we might see some creep into those from electrification, you know, very short-haul domestic flights, perhaps some ferry-type ships on short hauls, it's unlikely, you know, in the course of this century, we're going to see the likes of an A380 flying from, you know, Abu Dhabi to Sydney on electricity. The technology just isn't there today to do anything like that. And so with the expansion in the global economy, the expansion in global population, and therefore the expansion in energy use, you end up with still quite a significant CO2 emission to the atmosphere. Even though you've decarbonized the power sector, even though you've decarbonized much of the sort of passenger vehicle sector and so on, you're still left with these big sources. And so then you have to think about, how do I get to this net zero emissions? And this is one way in which we looked at it. So we've got about, you know, getting towards 6 gigatons of CO2 or carbon embedded in materials. And this is everything from plastics to housing stock to bitumen on your road. This is, you know, the complete picture of CO2 or carbon embedded in materials. Then you have a very big role, 7 gigatons of CCS in the industrial sector, maybe even air capture with geological storage in the second half of the century. But you still have something like 7 billion tons of emissions. But that's not the whole energy system. There's actually 3 parts to the energy system here. There's the fossil fuel sector that's left. Then you have this very large bioenergy sector. And of course, you've got the non-emitting sector, which is the solar and the wind and the nuclear, which isn't shown here, which is also, of course, very, very large. So in this biomass sector, which is everything from using biomass in power stations right through to biomass being converted to liquids for instance, aviation or for some particular uses, you've got a drawdown from the atmosphere of about 21 gigatons of CO2. So this is just the CO2 that's going from the atmosphere into the plants that you're actually using in the energy system. Now, of course, a lot of that's re-emitted as that bioenergy is used, and that's about 10 gigatons, as you can see. But then there's a second role for CCS here, and that is CCS being attached to the use of biomass. And there's some examples like that already appearing around the world, particularly in ethanol manufacture in the United States. So when you make ethanol manufacture, when you manufacture ethanol, there's a fermentation stage, and that emits pure CO2. This is what makes your bread rise when you make bread. It's CO2 from the yeast that causes it to rise. That's pretty much the same process that's going on when you're making ethanol. And so this is pure CO2. It's relatively easy to capture, relatively low cost, and it goes into the US EOR network. And so that's an example of actually drawing down CO2 from the atmosphere using CCS. And so overall, then we end up with a picture where we've got about a -7 gigatons. So a negative emission sector is in the form of from biomass, and that then compensates for the remaining emissions in the fossil fuel sector, and that gives you the net zero emissions. You can see that CCS plays a formidable role in this. Now, I should say this isn't just CCS in an industrial application. This is the full scope of CCS, everything from reforestation right through to the sorts of projects that you've heard about, for instance, in Abu Dhabi today, and the sorts of projects I'm going to tell you about in a minute. But I just thought I'd share that because it gives you a picture of where we're going rather than the pathway which we're on at the moment, or actually the pathway that we're not on at the moment, which is perhaps the more worrying finding. And so there's a significant role for CCS, and it brings about some real challenges, that it's operational, it works, but we can't seem to get across this hurdle of major deployment. We're looking for a number of policy mechanisms, and of course we're looking for society to embrace this technology to really get it to accelerate. So Shell's been working in this space for a number of years now. We've been an advocate of many of the mechanisms that you see in play today. And we've also constructed our own projects or been a participant in various other projects. And this just gives you a summary of what the company is doing. I guess the crown jewels are our Quest project. This is a project in the oil sands in Canada. It's an industrial CCS project. So from the hydrogen manufacture that takes place for the upgrading process, we capture the CO2 from the chemical release of CO2 as you steam reform methane, and that is stored. That goes to geological storage. So it's not an EOR project. This is actually a geological storage project. Then we're also involved through our technology company, CanSolve, which manufactures the amine chemicals, in the Boundary Dam project, which is a coal-fired power station in Canada. This is not our project by any stretch, but we're a participant from a technology perspective. As part of our acquisition of the BG Group, we are involved in a CCUS project in offshore in Brazil. We're a partner in the technology center in Mongstad. This is a center that researches carbon capture. A number of different technologies underway and in play at any one time to improve the overall technology of carbon capture and bring down that cost. We're a partner, although not the operator. Chevron is the operator in a very large project in Gorgon in Australia. That's an LNG project that's up and running, and the CCS part of that is now just starting to come online. And when that's up and running, it will store between 3 and 4 million tons per annum of CO2. So that's a real step up from most of the projects that you see around the world. And then the other project that we worked very hard towards, which just is a classic case of, the government support story, the crests and peaks of government support, was our Peterhead project in the UK, or in Scotland actually. And this was a gas-fired power station that was going to be built with offshore storage of CO2 in a depleted gas reservoir in the North Sea. It got within literally days of final investment decision, and the UK government, as part of a spending review, withdrew their financial support for the project, and it collapsed literally overnight. And that just goes to show you the sort of the perilous state we're still in with regards CCS technology and CCS support, that not all governments see the long-term picture here and have really understood the long-term ramifications of the actions that they're taking today by either supporting or not supporting CCS. So I'll finish there, and that gives us nearly half an hour for some questions and discussion with the panelists. And John, there's a spare microphone if you want to, or move it down there. Okay. And the floor is open to the audience to ask some questions. Yes, please. And if you could just say who you are as well.
Can I just get you to talk into this?
Thank you very much. My name is Reyadah Mandate. I'm from United Arab Emirates. And I just want to know, because you see all the presentations, they haven't touched about the possible risks and uncertainties associated with such projects. And I just want to know something about these risks, if possible, because for a long time we have been here, this sort of projects have been rejected by UNFCCC process because they have very high risks and uncertainties. And I just want to know from the practical point of view how they overcome such risks.
So that's a really critical question. And I think it hits right on the third part of my slide, which was society embracing the issue. Well, I'll start and then I think each of the panelists will have something very positive to say on that. From Shell's perspective, we see this as a very, very low risk. And I think you're referring, I guess, to the long-term leakage of CO2, because the industrial process itself that captures the CO2, transports the CO2 and injects the CO2 is made up of a set of processes that have been around for between 30 and 70 years with no issues. So, you know, the surface aspect of this is completely tried and tested. The subsurface area is something that, you know, the geologists are looking at very clearly and very carefully, and they have minimal concern about this. So, for instance, in our own project that was cancelled in the UK, we would have been storing the CO2 in a depleted gas well. So the fact that that gas was there and had been there for, you know, several million years was because that geological formation doesn't leak. If these geological formations leaked, then there would be no oil and gas in the world today. This oil and gas has been trapped in these formations for a very, very long time. And the goal of looking for CO2 storage is to either reuse these formations or to find similar formations where oil and gas hasn't collected, and to use it in the same application. So there's a very, very high level of confidence, simply because of, you might argue, you know, 10 million years of experience. But I will let the others enter into this.
Thank you for the question. I totally agree with David. What I would like to add is that the CCS was, I mean, for many, many years, it was led by the environmental side only. And it's very true. I mean, the assurances needed and the measures needed to ensure there's no leakage are very tough. However, on top of that as well is the financial side. So you have mainly two challenges. One, technical challenge, which is how to ensure the CO2 is going not to leak from the ground, assuming you have found a place where you're going to inject. Second one, who's going to finance it? And that's why most, if not all, of the CCS projects that have been seen in Norway, North Africa, did not last. Actually, some of them stopped because of technical reasons, the storage volume, or some of them, the financer could not continue to finance it. So CCS by itself, today, I think it has no much chance. We have to find another solution, which what we came up with is CO2 EOR. And it's there for the last 45 years, as I said. And when you go to CO2 EOR, you have an advantage of learning, so you can really control your injection, your tools to monitor how the CO2 is behaving in the reservoir. You don't have the issue of volume of storage because you expect that CO2 to come back. However, as I said, partially is going to be lost or stored in the reservoir through water. And because of that, the challenges that we've seen in the CCS are not really present in CO2 EOR. Nevertheless, you have other advantages, learnings, profit in terms of revenues, and technology development. So by doing CO2 EOR, in our opinion, we may be able in the future to reach partially the CCS objective. And with time, when our fields are empty or depleted, then we'll have natural locations to store that CO2. And we have some examples. Total, for example, in a place called Lac in the south of France, they have a gas reservoir which is depleted, and they stored CO2 in it, and they managed to store it and keep it underground for some years now and monitor it. So it's possible, but the time for CCS, I think, have a lot of challenges. We need to go through CO2 EOR first, where applicable. And if we can get more technology improvement, lower cost, then it can be applied, or CCS can be applied in areas where there is no EOR or oil and gas industry.
To add, because I agree that it's a very important issue, the safety. And well, back in 2005, IPCC issued a report where all the engineers and scientists who investigated the safety of CCS, they all concluded that there is 99% chance that CO2 will stay there and it's safe. So from a sort of human safety perspective, as David mentioned, as an industrial site, there hasn't been any issues, and we should maybe trust the engineers as we trust doctors, airplane pilots, so that it's safe. And also, we shouldn't forget that when CO2 is stored, it's 1 or 2 kilometers under the ground. It's not in the surface. It's very far. It's very deep. And people live near gas storage sites, which are maybe more dangerous if something happens. Imagine how gas can be explored. So from a safety point of view, what we hear from engineers, it's safe. From an environmental point of view, if there is a leakage, again, what David mentioned, it's very important to find the storage site that doesn't leak. And that's the key for CCS, to make sure that CO2 stays there. And for that reason, it's very important to have monitoring. And even for the EOR projects, it's very important to monitor what happens with CO2. And secondly, the issue of liability. So that's one of the issues also that creates a challenge for CCS projects. So at the beginning, during the operation stage, the company is responsible. It's liable for that CO2. So if there is a leak, it needs then to buy CO2 from somewhere else, because the purpose is to keep CO2 under the ground. But the issue of a longer-term liability is often not resolved, and the governments maybe should take that liability when the site is closed and the company moves away. Who is going to oversee the CO2 that's there for the next 100 years or whatever? So that's an issue and needs to be resolved, so that, again, with monitoring and surveillance, that CO2 stays underground.
Thank you. I got very little to add, but just a couple of things. I was talking to a geologist early last week, and I talked about permanent storage, and they said you can't talk about permanent storage in geological timescales. In 2 million years, an asteroid might hit the storage site. So geologists are not too concerned. I think the other 2 points, one. CCS is both accepted within the clean development mechanism, and it is also in the governing instrument of the Green Climate Fund as being an appropriate technology. So from that point of view, I think there is a recognition that CCS is an appropriate technology. On the length of storage, I think it was at COP21 we had a presentation from a European geologist who was looking at the Sleipner site and showed some 4D photography of the site over time, and you could see the CO2 plume moving within the storage site over time, and you could see that it was staying exactly where it was meant to be. So it's not only a question of as David said, we're putting it in places where we're pretty sure that that's where it's going to stay, but we are also, in monitoring, we're actually demonstrating that this is the case.
Yeah, thank you very much. I need to introduce myself a bit. I'm Joseph Isando Yedu, a delegate from Ghana, and also part of this CCS, I would say, stakeholders. Last week we were in Venice, right? and there was John, and these are some issues that came up. In fact, I was invited, the only person from Africa, because I've been making this presentation. And also I remember a team, the Egyptian party, and then the South Africa put very hard for inclusion of CCS with the CDM. Now you see that I made some few points. First of all is the stakeholder knowledge sharing. Most of you in Europe, you're talking about technology. Yes, we know about it, but knowledge sharing. How many of us, particularly those in Africa, know about this? They don't know. They see, some even think that geologically there's a cave down there where we are going to put the CO2 in there, and so one day it will escape. So that's the fear. Beside the long-term liability, and that is fine. Yes, so that is key thing, that we have to do more stakeholder knowledge sharing through workshops, seminars, particularly on the content. In fact, World Bank and then CTC and really charging some of us to really start something of that nature of the content. So today I was telling the delegate from Tanzania that I will send the slides to him so that you read and share among the African group. That's first point number one. Then number two, it comes to just a submission. I must support the submission made by Saudi Arabia. But I used to do all those things with your colleagues sometimes.
It's Emirates.
Emirates. Sorry.
Dubai.
Dubai. Sorry. I thought Saudi Arabia. Sorry. Forgive my ears. Anyway, fine. You see, we have to look at the CCS value chain and see which of the areas along the chain are now technical proving and can be marketable and market. You see, and start generating money to support the CCS. You see, otherwise, if you keep relying on government, the government is only going to take us like soccer ball, put us here today, kick us here today, and then we're not going anywhere. So that's it. Let's look along the value chain of the CCS. Which of the terms are profit and marketable and market and try to generate funds to support the industry. Like you mentioned, the EOR is really, that was my PhD title in Austin, Texas. If you Google, my name is there. It's already profitable. 60% already stored in the ground on the average. This is always the challenge. If people, the country and have more countries in Africa also, for the last 6 years, most of the discovery oil have been on the Africa. If more countries, and everybody wants to talk about whole production. And as I said, it also be seen as a way of also generating employment, wealth creation. You see, for us, particularly on the continent. And we have that. What there's like in Ghana, our economy is better. We don't find so many people traveling. Every year you find people trying to cross the Mediterranean and being killed or dying, being drowned in the sea. So which government will not be interested in a technology that will create jobs? It's about because the knowledge is not there, people don't know. So that's because I'm saying that knowledge sharing is very important. Look at the area. So now if more people start doing CCS for carbon capture for enhanced oil recovery, now we have also indirect technology transfer. And then over time, CC and the story itself will come. Because even within the developed world, the issue of long-term liability is a challenge. I keep telling people, when you look at the technology itself, the capture is more expensive and then the storage appears less expensive. But I can tell you, if somebody is going to have someone to monitor the place and also kind of thing, how budget, it could go high. You see, so first point, knowledge share, more workshops, seminars everywhere, particularly the country Africa. Then secondly, looking along the value chain, which is going to are marketable. And then we start encouraging like the enhanced oil recovery, more people being interested, and then with time you infuse in the idea of storage, and then to get clearer, better. Thank you very much.
Good. Thank you. Well, thank you very much for the intervention, because I think there's some really valuable lessons for everybody there about knowledge sharing, and particularly for GCCSI as you sort of ramp up again on CCS. So we've got another question in the middle there. The guy's got the box.
Yes. Hello. I'm Jonas Appelt from Forest of the World. I have two questions, but first a comment. I think a number of environmental NGOs would greatly disagree with the fact that just because a technology is included in the CDM mechanism that it can be considered environmental safe and sound, but that's just a comment. My question is first for Ms. Levina from the EIA. You have models from how to go from a 4-degree to a 2-degree scenario. And I saw agriculture included as a very small part, both now and in the future. But I didn't see land use, that land use change and the land sector that generally is acknowledged to have quite a large emission factor right now included in those scenarios. So I'd like to comment on what's included in the scenarios and what about sinks from the land sector, potential sinks from that. The other question is more general. I'm a novice in CCS, so I don't know too much about it. But if one of you can comment on how much energy is used when you store CO2 now, how much extra energy is used and how much extra CO2 is used per ton for storing a ton CO2.
Yes, thank you for your question. We model the energy sector. So we take from the global models, what's the share for energy, and then we model what the energy sector can do. So land use, we don't model because it's not our sector, but it is included. We look at the IPCC models that model the global CO2 emissions, including land use. And then we just extract the energy sector from there and we look at the energy sector. So that's implicitly it's included, but not in our models.
Okay. First of all, I think the comment from Ghana, I totally agree with you. Sharing learnings, as you saw in my presentation, is very important to collaborate and share information and lessons learned and expertise between different parties. And I think we're seeing a lot of CCS, CCUS workshops, venues worldwide. This week, there's another IEA workshop in Paris. Last week, we had a CSLF workshop for the whole week in Abu Dhabi, mainly about CCS. So there are a lot of venues, but maybe we need to do more so we can reach, especially Africa. I think Africa is not much involved into CCS. The question from regarding the net carbon of the operations, I can tell you for this kind, the first project that we have today, it is negative still. We are using a lot of power to capture CO2, to treat the CO2 and inject and get oil. But what I can tell you, that amount of oil that we're getting it from underground will be produced anyway, even without CO2 EUR. So what we're doing today by doing CO2 EUR, we are making our oil less in terms of net carbon. It's not negative, but still it is less than what if we did not do any CO2 injection. So we're trying to be, let's say, more efficient in terms of environment by reducing the carbon. With time, I have no doubt that the amount of power needed to capture CO2, because that's the main portion of the emissions, I can say, of the process, is going to go down because we'll have new technologies that need less power to capture same volume of CO2. So, but we need to start at a certain point of time. We cannot say it's still negative and that's it, we stop, we try something else. No, we have to do something. We have to go forward. We have to have that positive mind, although the net is negative today. Thank you.
So perhaps just to build on that question, because I think it's a good question. So in a power station setting such as the project we were looking at in the UK, where you're capturing CO2 from the flue gas of the power station, I think the energy penalty on the power station is somewhere around 25%. Yeah, so quite significant. But that being said, our CO2 capture plant in Canada has already demonstrated that, similar to the other experiences, that as we improve the technology, you would expect that to go down, and quite significantly. I think for some of the easier capture opportunities that exist today, so for instance, I talked about capturing CO2 from ethanol manufacturing. The penalty or the energy penalty is very, very small. And in fact, you can capture CO2 from these operations. I think it gets down to around $20 per ton. So much, much lower than the bigger industrial applications. Now, there aren't enough of those in the world to make a difference, but all of these types of projects are improving the overall learning. And I think most of the experience to date is in the area of amine capture. So this is using a refining technology that's about 50 years old. So we use amine technology in refineries to clean gases in refineries so that you're not emitting, certain gases into the atmosphere, for instance, to capture sulfur and so on. And they've been applied directly into the CO2 area to capture CO2 from flue gases. There's a lot of research going on in looking at completely different technologies, everything from different solvents right through to membranes. Now, we don't have a step change breakthrough in that yet, but there's a lot going on, and there's a lot of hope that there can be. So, but there's still a way to go on the existing technology. I think just if you look at the sort of the thermodynamic point at which you can't go below, I think it's about a 10 to 15% energy penalty if you stick with the amine technology. And that's roughly, I don't know the exact figures, but it's in that order, I think. Yeah. So thanks for the question. We've got a few minutes left. Are there any more?
Yeah, thank you.
You've got the box, go on.
Yeah, Niklas Roeming from Climate Analytics. I have a question. What has been mentioned two times by Mr. Scowcroft and Ms. Levine is that the IPCC scenarios heavily rely on CCS for achieving 2 degrees temperature target. I think there should be a differentiation there because most of the CCS deployed in these models is used for bioenergy CCS, net negative emissions. And I mean, during these discussions here, during the talks you gave that were very interesting, they only focused, except yours, Mr. Holm, on fossil fuel CCS. So I would like to know what you think about the long-term role of CCS might play in the negative emission technologies.
So it's a good point. So I think the bioenergy plus CCS is a technology that's just starting its journey today. So there's already bioenergy. So there's already biomass, for instance, that goes into some power stations. There's power generated from biomass. There's biomass added to coal-fired power stations, for instance, to limit the emissions. And in fact, one of the other projects in the UK that was cancelled as part of the overall cancellation of CCS was a coal-fired power station where they would have captured the CO2, but that coal-fired power station also burns biomass. So you would have had at least a beginnings of biomass to CCS. So I think biomass to power is a technology that's relatively mature today. And CCS from flue gas is a technology that has matured quickly. So the combination of those gives you an idea that this is feasible. Can all that compete in the power sector against renewables? Of course, is another question. And it would depend to some extent on the carbon price that prevails in the future to reach net zero emissions. And then I think the other area that so then you get into more exotic technologies like direct air capture, where you're actually capturing CO2 from the atmosphere directly. They still all have on the back of them geological storage of CO2, which is the technology that can be scaled and has been commercialized. So it's this front end that is still open for discussion. A first pilot plant of direct air capture is actually up and running now. It's in Switzerland, isn't it? Yeah, it's in Switzerland. Yeah. So, this is starting, and this isn't a technology that you don't really see appearing in the models until the second half of the century. So there's a long time to go to get it going. And of course, it would depend again on the CO2 price that's prevailing to incentivize it. But I think all of these can come together in one form or another. And then, of course, and these are really to offset the CO2 that you've got from places that you can't immediately capture, so like aviation. So the choices for aviation are either something completely different, which isn't appearing. It's substituting aviation fuels for a drop-in biofuel, so a biofuel that looks exactly like a synthetic hydrocarbon, or capturing the CO2 that the aviation is releasing into the atmosphere through a drawdown somewhere else. And in fact, that's the beginnings of what the aviation industry is looking at through their CORSIA program. So it's not targeted specifically at drawdown of CO2, but you can see that's the direction that they're heading, or one of the directions they're heading. So maybe if there's any other comments from the others.
I'd like to add for the IEA scenarios, we have bioenergy in both in 2DS and in 2 Celsius degree scenario and below 2 Celsius degree scenario. Combined with CCS, there is a small share in the 2DS scenario, and that share increases in below 2DS. And the big issue for biomass is that there are competing users for it. So if you look at the whole volume of bioenergy deployed in our scenarios, it stays the same in 2DS and below 2DS scenarios, but distribution is different. In 2DS, it's mostly used for heating and transport, a little bit with CCS. And in the below 2DS, the total remains the same, but there is a shift. There is increased role for negative emissions. So you have more bioenergy with CCS. But the issue also with biomass that it remains sustainable. Sustainable growth of bioenergy, sustainable use of it, because we also need land for food, and we need water for food and other uses. So there is this issue of sustainability that also needs to be addressed when looking at BECCS, bioenergy with CCS.
So I think somebody up the back's got the box, and that will be the last. All right, two last questions then. I may have to go before the last question.
Hello, my name is Denise from Cyprus. I was wondering if you could address a criticism that is often leveled against CCS, in that, at least in the context of energy demand and coal, that the CCS argument is being used to extend the lifespan of the coal industry, with coal globally starting to be seen as not viable, uneconomic, and CCS is almost attempting to extend its legitimacy by referring to it as clean coal. I ask this because it touches upon the broader question of, to what extent should global investment and innovation be significantly geared towards the renewable industry in superseding certain types of fossil fuel industry, such as coal, as opposed to using CCS to extend its lifespan?
Perhaps we could hear the other question from the guy next to you, and then we'll answer both and finish.
Thank you. My name is Csaba from Hungary, and I'm really not an expert on all this. So thank you very much for this presentation. It was really useful, at least to me. So just joining my colleagues from Africa, that there is a must to make all these information shared, not only on the developing country, but also on the developed ones. Yeah, coming back to the presentation, short and brief, really, because time is money, like we say. Well, capturing CO2 from the air, I would call it tree for the moment. But I know that we humans are very innovative. So yes, if there is something else that comes through the pipeline to capture carbon, it's very welcome. Anyhow, it's welcome that we do. I mean, humanity does something to store the CO2 on the ground, looking at the challenges to use land for different purposes. When it comes also to this inventiveness, I wonder, and this is my question, whether there is something also in using all these captured CO2 and stored CO2 for some reasons other than oil pumping out, which is also very beneficial, but still are there some other scientific, I don't know, evidences or research that is tending to use these stored carbon for some other reasons than that?
Okay, so can we, because people are starting to leave, so let's answer the two questions now. Okay, thank you. John, do you want to start?
Yeah, on the first point, I mean, and it's partly answering an earlier question, if you looked at my presentation, I'd said there was a significant part of CCS that was going to be would have to be applied to industrial sources. There are process emissions that there is no alternative, but or no alternative to carbon capture to reduce those emissions. So I regard CCS as a suite of technologies that will reduce emissions and from wherever they come. So I don't see it as related to any particular source. On the biomass issue, earlier this week there was a presentation, I think at one of the Thames, from a waste to energy plant in Oslo. That is actually is carbon neutral, and they are fitting CCS there, so it will actually become a carbon negative approach. So that is another biomass approach to CCS. On knowledge sharing, I think this is one of the things the Institute's very keen on, and we will be doing a lot of work on that in the coming years.
Right, anybody else? Because we apparently there's another event about to start.
I would like to add quickly on coal. So in the IEA scenarios, we see a lot of gas also with CCS. In addition to what John said on industrial sites, and my presentation pointed to that. If you look at the power, coal and gas, so gas becomes a high polluting, high carbon technology in below 2DS scenario, so it needs CCS. And for extending life of coal, coal power plants, they provide heat and electricity. So you cannot just get rid of them overnight. They have to continue working to provide services to people. So, and in our scenarios, we look at a lot of retrofitting, so adding CCS to existing coal power plants so that they continue providing services while we're getting our act together on other technologies and reducing emissions. And on knowledge sharing, just wanted to say at the IEA, we have international technology collaboration programs, and one of them is IEA GHG program. It's an international platform for CCS collaboration, knowledge sharing, so you can join that network.
Final point from you, Arif.
Or the Institute.
Thank you very much. Just to comment again on the coal, I think coal is the best example that we cannot live with only one source of energy. Coal was there, still there, despite of oil, gas, renewables. It's still there, and actually they are retrofitting all the plants, or some of the plants, to cope with the low emission era. So I don't think we should be biased of cutting down any source, because the global community needs all sources of energy. It's the energy mix. It's how to make the energy sources more efficient, whether commercially, technically, or environmentally. And that's why CCS plays a major role. Again, back to the point of sharing information, I think we have to work all together, different sectors, oil, gas, renewables, students, academia, researchers, IOCs, NOCs, all of them have to work together towards finding better solutions for our environment. Thank you.
Good. Well, thank you very much. Thanks to the GCCSI for hosting today, and thank you very much to the speakers. And another side event is starting, so thank you for coming.
Så skulle det i hvert fald have en anden.
Ja.
Asking or commenting, but even when I called women for 30 minutes, still there were men. Yeah. No, but I was like, yeah, well, I'm so sorry, but we're having
Okay, keep it on your phone.
scenarios.